Hello everyone, it's Paul with TutorU, and today we're going to be going over multiplying, dividing, adding, subtracting fractions, and those fractions will be simple fractions and fractions with unlike denominators. We will be continuing this series so you guys can get all of the learning done of fractions as what you possibly could want. Please be sure to watch the whole video because that will help you out the most, and if you feel like you've learned anything with fractions, please like, comment, and subscribe so we can help other people with their math needs. Otherwise, enjoy the video. I hope you have a beautiful day. I appreciate you. We have our first set of fractions, and we're going to be adding these simple fractions together. And I do have a little bit of a tip over here for you. It says simple fractions have the same denominator, bottom number, also known as the bottom number. All you need to do is add the top number. Pretty nice and easy. So for our very first one we have is 2 over 3 plus 1 over 3, and what our end result will be when we just add these two together, the top numbers, we will get 3 over 3. And you must simplify that. What is another way of thinking of 3 over 3? It's a whole. So 3 divided by 3 is 1 whole, or the number 1. We can then move down to our next set of fractions to add together, and we have 1 over 4 plus 2 over 4. And yet again, on this one, we're just going to add the top numbers together. So what is 1 plus 2? That is 3 over 4. Moving on to our next example of 2 over 7 plus 3 over 7, we get 5 over 7. And now our last fractions for this section of the video, we have 2 over 11 plus 8 over 11, also known as 10 over 11. And that concludes our first section of simple fractions. Moving on to subtraction, it is the same as adding, so just straight across the top. The first set of fractions we're going to find the difference of is 2 over 5 minus 3 over 5. So 2 minus 3, what is 2 take away 3? If you owe someone $3 and you only have 2, you are in debt by 1, so it is negative 1 over 5. Moving on to the next problem, we have 1/2 over 1/2, and this is actually a little bit of a unique fraction to be subtracting. It's the same fraction, so whatever you have, you're taking away the equal amount, so 1/2 minus 1/2, and that equals 0. Now we're on to our quarters, so we have 3/4, or 3 over 4, minus 1/4, or 1 over 4. So what is 3 take away 1? It is 2 over 4, and we can reduce this because we can divide both of these by 2, which gives us 1 over 2, and we're good with this one. Moving on to our last subtraction of simple fractions, we have 5 over 9 minus 2 over 9, so just 5 take away 2, that gives us 3 over 9, but these both can be divided by 3, so we can simplify this to 1 over 3, and we're good with subtraction. We now have our next set of fractions that we're going to be working with, and we're going to be multiplying simple fractions. Yet again, they still have the same bottom number, the same denominator. And the way that you multiply simple fractions is just how you multiply almost any other fraction. So we are going to multiply straight across, then simplify. It's super nice, super easy. So let's get started on multiplying our simple fractions. And that is 3 over 7 times 6 over 7. It's the first set of fractions we will be multiplying. So you multiply straight across, and that gives us 3 times 6 and 7 times 7. Also known as 18 over, and 7 times 7 is what? It is 49. And it is simplified already, so we are good to go with this one. We don't need to do anything else. We're good to move on to our next one, which is 2 over 3 times 1 over 3. And here, just multiply straight across again. So we have 2 times 1, which gives us 2, all over 3 times 3, and that is 9. Here we're good again. We don't need to simplify. There's nothing that can go into both 2 and 9 that will let us reduce this fraction down any farther. Let's see if we get lucky with our next problem. Here we have 3 times 5 and 6 times 6. So 3 times 5 is 15 and 6 times 6 is 36. And here we do have the number 3 that goes into both top and bottom, so we'll divide both of these by 3, and that gives us our end result of 5 over 12 as our end fraction. Boom. So now we are moving on to the very last fraction, last simple fraction. It is 2 over 5 times 3 over 5. Multiply straight across. 2 times 3 is 6. All over 5 times 5 is 25. And we do not have a fraction or a number that goes into both 6 or 25, so we are good to go. Let's move on to dividing simple fractions. Now we have our group of simple fractions that we're going to be dividing by, and let's see what our tip says. We must flip the second fraction, then multiply straight across. So it's very similar to multiplying fractions, except for we have this extra step. So we must first flip the second fraction, then we just multiply straight across. Easy peasy, lemon squeezy. So for our first set of fractions, we have 2 over 5 divided by 3 over 5. So we're going to just flip that second fraction, and I'll rewrite that. So we have 2 over 5. And it's multiplication now, 5 over 3, and we get 2 over 5 times 5 over 3, multiply straight across, and we get 10 over 15. We can then simplify this fraction because both the top and the bottom, the numerator and the denominator, can be divided by 5, giving us the result of 2 over 3, and that is our answer for this one. Our next problem is 1/2 divided by 1/2, so our actual problem is 1/2 times 2 over 1, and we just multiply straight across, giving us 2 over 2, and we can simplify this down to 1. Our next problem is 3 over 4 divided by 1 over 4. Rewritten, we get 3 over 4 times 4 over 1, and that equals 3 times 3 times 4 is 12. All over 4 times 1 is 4. 12 divided by 4 is 3, and we're good. Our last one is 5 over 9 divided by 2 over 9. So when we rewrite that, we get 5 over 9 times 9 over 2, and that equals 45 over 18. We can't really reduce this fraction, but it is improper, so let's make this a mixed number. And what do I mean by a mixed number? A mixed number is one where it has a whole integer with a fraction. So how many times does 18 go into 45? It goes into 45 2 whole times, leaving us with 9 left over. So we have 9 over 18. But we can still simplify this. We can divide both of these by 9, giving us 2 and 1/2 as our final answer. We are moving on to the next section where we have fractions with unlike denominators. And the key to fractions with unlike denominators with adding, we must find the LCD or least common denominator first. There is a shortcut method to adding fractions without having to follow this step exactly the way I'm going to show you, but you run into problems if you have to add any more fractions than 2. So the method I'm going to show you is, I like to think of it as a fancy 1. So let's talk about a fancy 1 at first. So we know that 1 is just the number 1. It's the loneliest number, but there is also 2 over 2, which is also 1. Now to freak everybody out with some letters, we have x over x, which is also 1, but not if it's 0. Then lastly, we have x plus 1 over x plus 1. As long as x is not -1, we're good. But this is just a fancy way of writing 1. So you might be wondering, why is this important? Well, let's just think about this problem here. We need to change these numbers. And a lot of people ask, like, what do you mean by changing numbers? Well, I want to make these bottom numbers match, but not change what's actually happening in the problem. And how am I going to do that? Well, I'm going to multiply by fancy ones, okay? So we can kind of see, there is that shortcut method of just multiplying the bottom numbers for our denominator, right? So in this instance, we know our denominator is 15. But now, let's use this fancy one idea. So how can we get 3 to turn into 15? What do we have to multiply 3 by to turn it into 15? Yep, we multiply it by 5. So let's go ahead and write that down there. And instead of just doing that, we're going to multiply by the fancy one version of 5. And we're going to multiply both the top and the bottom by 5. That gives us 10 over 15. And that's going to be added to, so now we have to do that fancy version of 1 over here to the 3 over 5. How can we turn the 5 into 15? Well, we multiply by 3 over 3. We now have to do that fancy version of 1 over here to 3 over 5. So what number times 5 gives us 15? Well, that is 3, and we have to do that to the top. So we have our fancy version of 1, but with the 3's. So 3 times 3 is 9, all over 15. And now we can go ahead and add, and our answer is 10 plus 9 is 19. All over 15, but 19 over 15 is an improper fraction. So we will rewrite that as 1. And what's left over of the 19 when we take away the whole 15 that made this 1? Well, it is 4 over 15, so 4/15. So our answer is 1 and 4/15. I will be doing more examples, but I really wanted to give this idea here its own space before we move on to like 2 or 3 more examples of adding fractions with different denominators. We are now going to do the long method of adding 2 fractions with unlike denominators. So we have 2 over 4 plus 2 over 5. We still need to find the least common denominator, and the way that we're going to do that is a little bit of the longer method of doing so. So we're going to list the 4 and the 5 down here, so our 2 denominators, and then we're going to multiply the 4 and the 5 by this row of numbers up above them. So 1, 2, 3, 4, 5. Going back over, it's 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, and 16, and 20. Moving down to 5, we have 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, and 5 times 5 is 25. You may notice that the 4 and the 5 have a common kind of meeting point. That is our lowest common denominator, and it is 20. So the denominator, we need to change this into the denominator of 20. So we're going to list the 2 over 4 down here, and we need to change this 2 over 4 into something that has the denominator of 20, right? So what did we multiply the 4 by to get the 20? We multiplied by 5. So we're going to multiply both the top and the bottom by the fancy version of 5. That gives us 5 times 2 on top, 5 times 4 on the bottom, equaling the 20 on the bottom, and 10 on top. If you see 10 over 20 is the same as 2 over 4, which is also 1/2, right? Then we'll go ahead and do the same thing to the 2 over the 5. So 2 over 5, 2/5. We had to multiply that by 4, so we'll multiply this up here by 4, so times and times. So 2 times 4 is 8, 5 times 4 is 20, so we're going to add the 8/20 to our 10/20, giving us 18/20, also known as, after we divide both the top and the bottom by 2, that is equal to 9 over 10, and we're good to go. Don't forget to circle your answer, and we'll move on to the next section. We are now moving on to subtracting fractions with unlike denominators, and the same rule applies. We must find the least common denominator between these two numbers. So we have 1/2 minus 1/7 equals a question mark. So what are we going to do? Well, we are going to find the least common denominator. So what is the least common denominator between 2 and 7? And just like the other shortcut method, we can already kind of see that it's going to be 14. How can we change 1 over 2 into something over 14? Well, we have to multiply the bottom by 7 and the top by 7. So don't forget your fancy version of 1. So 7 over 7, all of this times 1 over 2 minus, and then what are we going to multiply the 1 over 7 by? We are going to multiply that by our fancy version of 1 of 2 over 2 times the 1 over 7. And that gives us 7 over 14 minus 2 over 14. With our end result being 5 over 14. Don't forget to circle your answer, and we are done with subtracting fractions with unlike denominators. We are now moving on to multiplication of fractions with unlike denominators, and the main thing I want you to remember is that we are just going to multiply straight across, and we're going to simplify when needed. I have had students in the past that think that there is something to do with cross multiplication, but no, all we do is multiply straight across. So our first one is 2 over 3 times 1 over 10. 2 times 1 is 2, and 3 times 10 is 30. But we can reduce this because both of these numbers can be divided by 2, so this equals 1 over 15. Moving on to our next problem, yet again we are going to multiply straight across, so 3 times 1 is 3 all over 5 times 2 is 10. And can we reduce this problem? No, we cannot. There is not a number that can go into both 3 and 10, so we can't reduce it down. Now we have 2 over 5 times 1 over 11, so just still straight across, so 2 times 1 is 2 all over 5 times 11 is 55. 55 is an odd number, and 2 is like the Optimus Prime of even numbers, so there's nothing we can do here. This one is done. And now we're moving on to our last problem, and that is 3 over 7 times 1 over 3, and we're going straight across. So 3 times 1 is 3, all over 7 times 3 is 21. Now I'll ask you, is there a number that can go into 3 and 21 that can help us reduce this fraction? Well, yes, there is. It is 3. So we can divide both the top and the bottom by 3, and that equals 1 over 7. Don't forget to circle your answers. Your math teachers will love you a little bit more if you do that, because then it doesn't matter how messy it is. Well, actually it still does. I've seen some crazy things, but let's move on to the next section. Hello everyone, it's Paul with TutorU. I really hope that you enjoyed this video. I will be putting out additional videos to help you out with fractions, but if you really could help me out here and help other people's out, please go ahead and hit the subscribe button. And of course, I'm gonna let YouTube recommend whatever video you want to watch next, or you can just watch one of mine after you subscribe. But I hope you have a beautiful day, and I appreciate you.